Lesson number 5, we're going to talk about geometric sequences. So before lesson 5, we've been looking at arithmetic or arithmetic sequences where we have a difference and it's either a positive or a negative that we are adding each time to our subsequent terms. And so let's look at this warm-up. Consider the following two sequences, 2, 4, 6, 8, and 2, 4, 8, 16. Explain how to calculate T5 and T6 for each sequence and state the value of each term. So starting with this one here, 2, 4, 6, 8. So we have term 1, term 2, term 3, and term 4. If I want to find term 5, I got to find out, well, what does each term, what does it change by? And so for this one here, I need to add 2 to the previous term, and so I know that the next term, term 5, would equal 10. So add 2 to previous term, which means that if term 4 was 8, then term 5 must equal 10, and term 6 must equal 12. Now if I look at the second one, 2, 4, 8, 16, to get from 2 to 4, I can either add 2, but to get from 4 to 8, if I add 2, I'll be at 6 for my third term. So I had to multiply by 2 to get from 4 to 8, which also works from 2 to 4 for my term 1 and term 2. And for my fourth term, I had to multiply 8 by 2, which means that for my fifth term, I'm going to have to multiply by 2 as well. So multiply the previous term by 2. So that means that term 5 would equal 32, and term 6, if I multiply term 5 by 2, is going to equal 64. So a geometric sequence is what we have in our second example here. And a geometric sequence is just a sequence that we get when we are multiplying the subsequent terms by a constant. And so for example, 3, 6, 12, 24 is a geometric sequence because we're multiplying each previous term by 2. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and if we multiply 24 by 2, we're going to get 48, which would be our next term in that sequence. So the value of the constant can be found by dividing the second term by the first term or the previous term. So if I wanted to get my my common ratio between these two, all I would have to do is divide 6 by 3. That would give me 2. 12 divided by 6 would give me 2. 24 divided by 12 would give me 2. So in this example, if I divide T2 by T1 or T4 by T3, then the example here, my constant is 2. So make sure you read these boxes. What we just discovered here is what's known as a common ratio. That's the constant between our terms in a geometric sequence. That's known as the common ratio. And if we were looking for the formula for that, it would just be Tn divided by Tn minus 1 is equal to R. And your value of n has to be greater than or equal to 2. And we're working with our set of natural numbers. So with this next example, or this first example, which is class example number 1, we want to explain why each of the geometric sequences is geometric. So we're going to plug it into our common ratio formula, where we have Tn divided by Tn minus 1. So if n is equal to 2, so T2 divided by T1, n minus 1 would be T1, then what I'm working with here is 12 divided by 6. And 12 divided by 6 would also be equal to all the other subsequent terms, so 48 divided by 24, and that's going to be 2 as well. So that's what my common ratio is equal to. Same thing over here, I'll plug it into the same formula, but this time I'm going to show you that term 2 divided by term 1 is equal to term 3 divided by term 2, which is equal to term 4 divided by term 3. So 5 divided by negative 1 is equal to negative 5. This might be a little helpful for you here. Term 3 divided by term 2, so negative 25 divided by 5 is equal to negative 5. Right? Term 4 divided by term 3, 125 divided by negative 25 is also equal to negative 5. Oh, sorry. Messed that one up. Divided by negative 25 is equal to negative 5. So here our common ratio is the same between each term. And it'll be the same thing that we're going to do in this example where I have T2 divided by T1 is equal to T3 divided by T2, which is equal to T4 divided by T3. So negative 5 divided by negative 10, we're going to get a common ratio of 1/2. Negative 5/2 divided by negative 5, we're going to get a common ratio of 1/2. I should square those answers, or circle those answers. All right, next example. For the following sequence, identify the type of sequence, arithmetic, or geometric. State the common ratio or common difference, depending on the sequence. And then we want to state the fifth and the sixth term for each. So first, let's look at this 8, 24, 72, 216. Well, I know that 8 times 3 is 24. I also know that 24 times 3 is 72. And if I were to go 72 times 3, we're going to get 216. So this one is, in fact, geometric. And my common ratio is equal to T2 divided by T1, which is equal to 24 divided by 8, or 3. If I wanted to find out what my next term was, term 5 will be term 4 times 3, so 648. Term 5 is 648, and term 6 is going to equal 1944. It's 1944. Next we have this sequence here, so 108, 72, 36, 0. It looks like it's being, there's a common difference of 72. 36 is half of 72. So it looks like there's a common difference of negative 36 each time, which means that if it's a difference, and this one was a common ratio, then this one would be arithmetic. So we have a value of d there, so we have 108, or T2 minus T1, 72 minus 108 is equal to negative 36, and 72 plus a negative 36 is 36, which means that T5 is going to equal negative 36 if I add negative 36 to 0, and T6 is going to equal negative 72 if I add negative 36 to negative 36. And my last term, or my last question, which is C, negative 3 to negative 4/3 and 8/9. Well, let's find out what's going to happen when I do T2. It does not look like it's arithmetic, which means it has to be geometric in this case. Sometimes it's neither, but we're only given 2 options, so I know it's either arithmetic or geometric. And since it's not arithmetic, it has to be geometric. So my common ratio, however, R, is going to be equal to T2 divided by T1, which is equal to T3 divided by T2. So my ratio ends up being 2 divided by negative 3, or my ratio is negative 2/3. And my term 5 is just going to be term 4 times 2 over negative 3. So term 5 is going to be negative 4 over 3 times 2 over negative 3. Excuse me. And so negative 2/3 and oh, sorry, I'm looking at the wrong one. My term 5 is going to be positive 8 over 9. Sorry. So term 4 is 8/9, not negative 4/3. So I'm going to have negative 16. 8 times 2 is 16. Negative 8 times 2 is 16. And 9 times 3 is 27. So that's my fifth term. Sixth term is going to be negative 16 times 2 over negative 3. So negative 16 times 2 is 32. And 27 times 3 is 81. And it's positive because we have a negative times a negative. All right, next we're working with a word problem. So in our investigation, consider the following. A university marine biologist or marine biology student studies the growth of a strand of moss by observing the change in its weight every day. And this table shows the mass of the moss in grams at 12 noon on each day for the first 4 days. So what they want us to do, the masses form a geometric sequence, state the common ratio. So our common ratio here for our masses, 8, 12, 18, 27. What is that common ratio? So R, remember, is equal to T2 over T1. So since we're just told that it forms a common ratio, I'm just going to use these first two terms. So term 2 is 12 divided by 8. We have a fraction here, and so we can't use 12/8 as our ratio. We have to use the simplest form. So 4 goes into both of these. So 4 goes into 12 3 times and goes into 8 twice, which is 3/2, which is the same thing as 1.5. So next, let A equal the first term, which is 8, and R the common ratio, which we found out to be 1.5. Now complete the following table. So the first 3 terms are already done for us. Our next term, however, term 4, is not completed. So to get to term 2, we went 8 times 1/2 and equals 12. Term 3 would be 8 times 1/2 times another 1/2 would be 18, which means term 4 would be 8 times 1/2 times 1/2 times another 1/2 to give me 27. And that means that term 4 would equal A times R. And if my common ratio is 1.5, then I have 1, 2, 3 1.5s. So R to the power of 3. So now we can kind of see how this formula is developing. So term 5 would be 8 times 1.5 times 1.5 times 1.5 times 1.5. 27 times 1.5 would give me 40.5. Or A first term times R to the power of 4. So any term, and we won't use A, what we're talking about Tn here, is equal to A R to the power n minus 1. Because it was taking each number of terms, for example here, 5, and it's subtracting 1 to give me 4. Term 4, subtracting 1 giving me 3. So it's taking your term number and then subtracting 1 each time. So the formula for the general term of our sequence is going to be T n is equal to A times R to the power of n minus 1. This gives us our general term for our geometric sequences outlined in these boxes below. Tn is equal to our first term multiplied by our common ratio to the n minus 1th power. So Tn, again, is the general term of the sequence. A is equal to the term 1, or the first term. R is our common ratio, and n is whatever position that term is. So if it's term 4, then n would equal 4. All right, so next, you can do this on your own time if you'd like, but basically you want to just follow this pattern or make your own pattern using this formula. Class example number 3, determine the formula for the general term and calculate the indicated term for each of the following. So we want to calculate T9, but we want to find out what our value of R is and what our formula is going to be. So first of all, let's start with listing our known variables. A, first term, is 5. Common ratio, well, yeah, from 5 to 15, the ratio has to be 3. And that's all the information we need to know. So my general formula is going to be Tn is equal to AR n minus 1. So 5, 3, n minus 1. 5 times 3 to the power of n minus 1. And if I want to calculate term 9, then I'm going to plug it into this general formula. So 5 times 3 to the power of 9 minus 1, or to the power of 8. So when we're typing this into our calculators, brackets are important. This hat thing here I used will raise to the power, so I'll type that again. 5 times 3 raised to the power of 8 is 32,805. And that's our 9th term. Next question. First term, 1/3. The ratio, well, we got to go term 2 divided by term 1. So T2 is negative 1 over 6 divided by 1/3. Or if we're dividing fractions, another way we can do this is just multiplying it, right? So if you're stuck with fractions, then remember, if I'm working with fractions, then negative 1/6 times 3 over 1 is the same thing as dividing by 1/3, which would give me negative 1/2 or 3 over 6. So that's my common ratio right there. So let's apply that to a formula. So Tn is equal to AR to the n minus 1. Tn is equal to A being 1/3, my common ratio being negative 1/2 to the n minus 1. So if we're looking for in this case, the 7th term, then term 7 is going to equal 1 over 3 times negative 1/2 to the 7 minus 1, or 6 to its power. So 1 over 3. When you're using fractions like this, I recommend using brackets just so you don't have anything lost in your calculation. And something nice with these calculators is they'll convert to fractions for us. So again, 1 divided by 3 times negative 0.5 or 1/2 to the power of 6. And I can convert to fraction just like that. So I have 1 over 192. Class example number 4. I want to use the general term of the formula to write and simplify an equation which can be solved to determine the number of terms. So I need to come up with a general formula for this problem. So A is term 1, which would in this case be 32. My common ratio, well, from 32 to 64 is 2, is a ratio of 2. 64 to 128 is a ratio of 2. My general term, or general formula, is A to R n minus 1. And yeah, if I want to use the general formula to write and simplify an equation which can be solved to determine the number of terms. So I know that this is my last term, which we will call Tn. Tn is equal to 16,384, and that is equal to 32 to n minus 1. So we are going to need to simplify here. So in order to separate this part of my equation, I need to divide both sides by 32. So 16,384 divided by 32 gives me 512 to the 2n minus 1. Now notice how the unknown I'm trying to solve for is an exponent, right? So in order to determine what that exponent is going to be, I need to think about my common bases. So if I have 512 is equal to 2n, 2 to the power of n minus 1, I need to find a common base between 512 and 2. So can I write 512 for base with a base of 2? So 2 to the power of something equals 512. So this is where you can use a number of methods, and I'll just show you the guess and check method. So that's which when you plug in numbers and see which ones work. So 2 to the power of 9 is equal to 2 to the n minus 1. And so now that I have similar bases, I can get rid of them using our exponent laws. 9 is equal to n minus 1. Solve for the value of n, so I got to add my 1 to both sides. 10 is equal to n. So there are 10 terms. Next question, Janice used guess and check to write each side of the equation. And we just did that, so yeah, you can skip this section here. And then Gary used his graphing calculator. So this is where it's really good to have this graphing calculator, because if you have another one, this video won't be helpful because I only have, this is the kind that I use and recommend. So yeah, it'd be a lot more helpful for you if you had this kind of graphing calculator. So I'm gonna plug in both sides of my equation. So 2 to the power of x minus 1. So the x function is right here. And for my second line, I'm just going to put 512. And I need to change my window settings in order to encompass these values. So for my x min, so the minimum value of my x's is going to be -2. It's going to have a scale of 2 and a max of 20. And for my y min, it's going to be 0 to 1,000 to 100. And then I'm going to graph. Next thing I want to do is I want to find out where this intersects. And so all I got to do for that is I need to use my intersect function, which is second function, trace, and then option 5. And it wants us to kind of guess where it's going to be, and then it'll spit out our answer, which is x equals 10. So that's how you would use the calculator. I will help you with this section in class if you're having difficulties with that. Next we're going to be looking at the geometric means, but I'll save this part for another video.